order for us to do our project on food relating to calculus, we had to find something that's both tasty and is an application for Newton's law of cooling. We decided on making fresh brownies. In the video, Arnav bakes some delicious brownies from scratch.
So we use Newton's law of cooling to determine how long it would take for the brownie to cool down and be safe to eat. So we have 4 different givens. At time equals 0 minutes, the temperature of the brownie is 212 degrees. At time equal to 2 minutes, the temperature of the brownie is 181 degrees. The room temperature is 72 degrees, and the temperature for the brownie to be safe to eat is 83 degrees Fahrenheit. So we know that the dirt is equal to negative k times t minus ta. So if we do differential equation, we'll get t is equal to c times e to the power of negative kt plus ta. So first off, we need to solve for c. So when we solve for c, we sub in when time is equal to 0. When time is equal to 0, it is 212 degrees Fahrenheit. Therefore, when we solve for c, it's 212 minus 72, which is 140. So when t is equal to, next we would solve for k. So we plug in when time is equal to 2 minutes. So when time is equal to 2 minutes, the temperature is 181 degrees. So when we solve it, k will equal to 0.125. Next, we will solve for the time it takes for it to cool down to 83 degrees Fahrenheit. So we know that the temperature has to be 83 degrees, and then we also know k is 0.125 and c is 140. We put that in the equation, we plug it in, and the time is equal to 20.326 minutes. So in order for the food to be safe enough to eat, we have to wait around 20 minutes.
We are now trying to find the temperature after 10 minutes while it is heating. This time it's not cooling down, it's heating up while it's in the oven. So the givens for this one is at time t equals 0, the brownie mix will be at room temperature, which is 72 degrees Fahrenheit. At 33 minutes, the temperature of the brownie mix will become 212 degrees Fahrenheit, which is the start for the first question. The temperature of the preheated oven is 340 degrees Fahrenheit throughout the entire thing, so that's going to be our ambient temperature. And we are trying to find the temperature at 10 minutes, which I already said. So Newton's law of cooling is change in temperature is equal to negative k times the current temperature of the object minus the ambient temperature of the object of the area, where the constant k is greater than 0. Separating the variables and solving for t, you get t is equal to some constant c times e to the power of negative kt plus the ambient temperature. So for this model, the ambient temperature is 340, and yeah, so first we need to solve for c. So write the equation down. T is equal to c e to the power of negative kt plus 340. T of 0 is equal to c times e to the power of 0 times negative k is just 0, so e to the 0 is just 1. So 72 is equal to c plus 340. So therefore c is equal to 72 minus 340, which is equal to negative 268. So now we found c. Now we need to find k. To find k, we already were given a point, which is 33 and 212. So at time 33 minutes, you have 212 degrees Fahrenheit. So when you plug this in, you get 212 degrees Fahrenheit is equal to negative 268, which is c, times e to the power of negative 33 times k, whole thing plus 340. Solving for k, you get natural log of 212 minus 340 whole divided by negative 268, and that entire thing divided by negative 33. And this, plugging into a calculator, you get 0.022392678. So now all we have to do is just plug in 10 for t, your t function. So t of 10 is equal to negative 268, which is c, times e to the power of negative k times 10. K is just 0.022392678, and you add that to the ambient temperature, which is 340. So plugging this in to a calculator, you get 125.768 degrees Fahrenheit, which is approximately 126. So after 10 minutes of staying in the oven, the baking mix goes from 72 degrees Fahrenheit to approximately 126. And this will work for almost any t value